Brian Cox, the well-known physicist and science communicator, has recently made headlines with a striking warning about an unusual and mysterious phenomenon linked to the famous star Betelgeuse. Positioned prominently in Orion's shoulder, Betelgeuse has long been one of the brightest and most studied stars in the night sky. But now, according to Cox and other observers, something strange is happening. Betelgeuse has started to dim in a way that's caught the attention of astronomers everywhere. This isn't just a regular fluctuation. It might be a signal of something far more serious happening inside the star's core. The question now is, what exactly is going on? Some experts speculate that this dimming could mean Betelgeuse is preparing for its final act, a massive supernova explosion. Others think it might be the result of more subtle and complex stellar dynamics that we're only beginning to understand. Either way, this isn't just any star we're talking about. Betelgeuse is a giant among giants, a red supergiant that dwarfs our own sun in size and mass. If something is changing deep within Betelgeuse, it might offer scientists a front-row seat to one of the universe's most dramatic and rare events, the death of a massive star. When we talk about massive bodies in space, Betelgeuse is practically a cosmic colossus. It's not just large, it's absolutely gigantic. To give you some idea, if Betelgeuse were placed at the center of our solar system, its surface would stretch far past Mercury, Venus, Earth, and even Mars, extending deep into the asteroid belt. Its sheer size is enough to make it one of the most prominent objects we can see from Earth. The star's brightness fluctuates between magnitudes 0.0 and 1.6, making it one of the most variable of the first magnitude stars in our sky. That variability, combined with its immense size, makes Betelgeuse fascinating and unpredictable. If you tried to compare it with everyday objects, imagine shrinking our sun down to the size of a ping-pong ball. In that case, Betelgeuse would be the size of an entire football stadium. Its mass is estimated to be somewhere between just under 10 and a little more than 20 times the mass of our sun. And while that might not seem like a big range, even small differences in stellar mass can lead to very different fates for stars. And its distance? That's been surprisingly hard to pin down. Astronomers estimate that Betelgeuse is somewhere between 400 and 600 light-years away from Earth. That sounds pretty close in cosmic terms, and it is. Despite being relatively young, just under 10 million years old, Betelgeuse is nearing the end of its stellar life. Its mass has caused it to burn through its fuel much faster than smaller stars like our sun. Scientists believe that when its time comes, Betelgeuse will go supernova in spectacular fashion, shining as bright as the half-moon in our sky for weeks, maybe even months. The explosion will be visible even during the day, but Earth, fortunately, will remain completely safe. What makes Betelgeuse even more interesting is its motion. This isn't a star that sits still. In fact, Betelgeuse is a runaway star, meaning it's moving unusually fast compared to other stars in its area. Astronomers believe it was ejected from its birthplace in the Orion OB1 association, near Orion's belt, and is now speeding through space at about 30 kilometers per second. That's fast enough to leave a massive bow shock in the interstellar medium behind it, stretching more than 4 light-years wide. This tells us that Betelgeuse's past was likely turbulent, possibly involving gravitational drama with other stars. Back in the 1920s, Betelgeuse made history by becoming the first star outside our solar system to have its photosphere, the visible surface, measured. Since then, astronomers have continued to track its apparent diameter, which ranges from 0.042 to 0.056 arcseconds. Why the variation? It's because Betelgeuse isn't perfectly spherical. Its shape and appearance shift depending on the wavelength of light used to observe it. These irregularities offer a glimpse into the chaotic environment of a red supergiant's outer layers, filled with convection cells, turbulence, and fluctuating emissions. But Betelgeuse isn't just a lone wanderer in the night sky. It's surrounded by a vast and asymmetric cloud of material, a kind of outer envelope created by the star shedding mass over time. This cloud is estimated to be around 250 times the size of the star itself, making it one of the most spectacular sights in astronomy. And when seen from Earth, Betelgeuse's apparent diameter is surpassed by only a few other stars, most notably our own Sunday. This shows just how close and how large Betelgeuse is, even compared to other distant giants. In terms of classification, Betelgeuse is identified as an M1-2 type red supergiant. This designation gives astronomers a lot of information about its nature. The M indicates its reddish color and relatively cool surface temperature, while the I and B label it as an intermediate luminosity supergiant, right between a regular supergiant and a truly luminous one. Interestingly, Betelgeuse's spectral fingerprint has been used as a standard reference point for other stars since 1943. Yet despite this, it remains surprisingly difficult to nail down the star's exact luminosity. That difficulty stems from a number of factors. The star's surface temperature varies, its diameter changes over time, and its distance from Earth still isn't precisely known. Even so, the most recent estimates put its luminosity at around 126,000 times that of our Sun. That's absolutely staggering, and it underscores the tremendous energy Betelgeuse is radiating into space. It's located roughly 200 parsecs, or about 650 light-years, away, and its surface temperature ranges between 3,250 and 3,690 Kelvin. These variations are due to its pulsations, which cause the star to swell and contract in a continuous cycle. One of the most surprising things about Betelgeuse is how slowly it rotates. While our Sun spins relatively quickly, Betelgeuse takes its time, rotating at just 5.5 kilometers per second. That's incredibly slow for a star of its size. In fact, it takes Betelgeuse about 36 years to complete one full rotation. Its rotational axis is tilted at roughly 60 degrees to Earth, which gives astronomers a unique view of the star's equator and poles. Despite this sluggish rotation, scientists suspect the star still exhibits magnetic activity, a rarity for a red supergiant. This suspicion was confirmed in 2010, when observations using a telescope at the Pic du Midi Observatory revealed a weak magnetic field at Betelgeuse's surface. This was a huge discovery as it indicated the presence of a dynamo effect, a process usually driven by fast-moving, convective gas within a star. In Betelgeuse's case, massive convective cells in its outer envelope could be generating this magnetic field, subtly influencing the star's wind patterns and its rate of mass loss. These fields might also affect the asymmetric structure of its surrounding cloud of dust and gas. Betelgeuse's movement through space has baffled astronomers for years. When scientists trace the star's path backward through time, they find that it doesn't align neatly with any known stellar nursery or birth cluster. In fact, it appears to have originated from a region in space where no significant star-forming activity is known to have occurred. This has led to the theory that Betelgeuse may have been part of a high-mass multiple star system, possibly ejected due to a gravitational interaction or a nearby supernova explosion that disrupted its original neighborhood. In 2013, the Herschel Space Observatory revealed another clue: shockwaves created by Betelgeuse's powerful stellar winds colliding with the interstellar medium. These waves form a kind of ripple pattern in space, like the wake behind a speeding boat, and stretch for light years in every direction. The origin story of Betelgeuse continues to evolve as more data comes in. The most widely accepted theory suggests that the star was born within the Orion OB1 association, possibly within a high-mass subgroup known as OB1A, around 10 to 12 million years ago. That's relatively young in stellar terms, but it's aging fast. Because Betelgeuse is so massive, it's been burning through its nuclear fuel much faster than stars like our Sun. When stars like Betelgeuse exhaust their supply of hydrogen, they begin fusing heavier elements in a series of increasingly unstable reactions. Right now, it's believed that Betelgeuse has likely moved on to fusing helium, carbon, and maybe even heavier elements like oxygen and silicon. Each of these stages lasts progressively shorter amounts of time, which means we could be approaching the final stage of its life. This is why scientists are paying extra close attention. It's the calm before a cosmic storm. One of the main reasons Betelgeuse captured global headlines recently was the strange dimming event observed in late 2019 and early 2020. Suddenly, the star's brightness began to drop dramatically, reducing its visibility in the night sky and leaving astronomers scrambling for explanations. This was no small fluctuation. Betelgeuse dimmed by almost 60%, which was unheard of for this particular star. At first, many wondered whether this was it, whether the star was about to go supernova. Scientists around the world turned their telescopes toward Orion, eager to catch the possible final moments of a stellar giant. But as quickly as it dimmed, Betelgeuse began to brighten again. The star returned to more typical levels of brightness, leaving astronomers both relieved and puzzled. Later studies suggested that the dimming may have been caused by a massive dust cloud ejected from the star itself. Essentially, Betelgeuse might have belched out a cloud of material that temporarily blocked some of its light from reaching Earth. It's as if the star had a cosmic cough, and that brief moment caused us all to panic. However, the event also revealed just how active and unstable Betelgeuse really is. Even more surprisingly, the dust cloud theory got strong support from observations made by the Hubble Space Telescope and the Very Large Telescope in Chile. These instruments captured actual images of the star's surface and its surrounding environment before, during, and after the dimming. The data showed a noticeable bulge on one side of the star and a shift in its outer layers, clear signs of a significant mass ejection. This confirmed that Betelgeuse wasn't just dimming randomly, it was undergoing massive internal changes that were physically reshaping its appearance and possibly signaling the final phase of its life. And this brings us back to Brian Cox's recent comments. According to Cox and other astrophysicists, Betelgeuse's erratic behavior is consistent with what we'd expect to see from a star nearing the end of its life. While nobody can say for sure when it will explode, the warning signs are starting to pile up. We're witnessing massive mass ejections, irregular dimming, changing magnetic fields, and internal instability, all of which suggest the star is entering its final stages. If Betelgeuse does go supernova soon, it will be one of the most extraordinary events humanity has ever seen with the naked eye. The idea of a visible supernova might sound like science fiction, but in Betelgeuse's case, it's very real. When the star finally collapses, it will do so in dramatic fashion. Its core will collapse under its own gravity in less than a second, triggering an explosive shockwave that rips through its outer layers. The resulting supernova will be so bright that it will rival the full moon in the night sky. For weeks, it may even be visible during the day. The entire Orion constellation will appear dramatically different for a period, and it will become the astronomical event of a lifetime. Despite all this drama, there's no danger to life on Earth. The supernova explosion, while powerful, will occur at a safe distance, far beyond the reach of any harmful radiation. Gamma-ray bursts, which are sometimes associated with supernovae, are not expected from Betelgeuse, especially given its rotation and orientation relative to Earth. That means we'll get to witness a spectacular show without any risk. Think of it as a cosmic fireworks display, one that's been millions of years in the making. Astronomers will use every tool available to monitor and study it in real time when it happens. But the scientific value of such an event goes far beyond just pretty lights in the sky. If Betelgeuse explodes during our lifetime, it will provide a once-in-a-century opportunity to study a core collapse supernova from start to finish. We'll be able to observe everything from the initial shockwave to the formation of a neutron star or possibly even a black hole. It will give researchers critical data that could transform our understanding of stellar evolution, nuclear physics, and even gravitational waves. For physicists like Brian Cox, this is the kind of moment that redefines what we know about the universe. There's also the emotional element to consider. For thousands of years, humans have looked up at the stars with wonder, curiosity, and hope. Betelgeuse has been a constant companion in the night sky, part of myths and stories across many cultures. From the ancient Egyptians and Greeks to modern stargazers, this brilliant red star has played a role in our shared human experience. Watching it change, and possibly disappear, would be a profound reminder that the universe is alive, dynamic, and constantly evolving. It's a humbling moment that connects us all through time and space. The supernova would also change how we teach and learn about space. Imagine future generations growing up with photos and videos of the Betelgeuse supernova in textbooks and documentaries. It would become a touchstone in astronomy, much like the 1987A supernova was for a previous generation of scientists. But unlike 1987A, which occurred in the Large Magellanic Cloud over 160,000 light-years away, Betelgeuse is practically next door. Its explosion would be clearer, brighter, and far more detailed in terms of what we could observe with modern instruments, from visible light to X-rays and neutrinos. And then there's the mystery of what comes after. Once Betelgeuse goes supernova, what will be left behind? The most likely outcome is a neutron star, a dense, spinning object made almost entirely of neutrons, packing more mass than the Sun into a sphere the size of a city. But if Betelgeuse is closer to the high end of its estimated mass range, there's a chance it could collapse further into a black hole. That's the ultimate cosmic enigma, a region of space where gravity is so intense that not even light can escape. Either outcome would reshape our understanding of stellar death. For now, though, we wait. Astronomers around the globe are keeping a close eye on Betelgeuse, watching for any new signs of instability. They're using everything from ground-based telescopes to orbiting observatories to monitor its brightness, temperature, and spectral changes. Even amateur astronomers are part of this global effort, contributing data that helps track the star's behavior. It's a collective human effort, scientists and citizens alike, focused on understanding one of the universe's oldest and most powerful processes. We're all waiting for the moment when Betelgeuse finally lets go of its final breath and lights up the sky. And while it might not happen today, tomorrow, or even in the next century, one thing is certain. Betelgeuse is on a ticking clock. His time is running out. When that moment comes, the world will stop to witness it. News channels will break the story, social media will light up, and billions of people will look up at the sky in awe. For a brief moment, our planet will be united by a single event, a celestial show that reminds us of our tiny place in a vast and ever-changing universe. And maybe, just maybe, it will inspire the next generation of explorers to reach for the stars. Until then, we can only observe and wonder. But one thing's for sure, Betelgeuse won't go quietly. Its final act promises to be nothing short of legendary. And thanks to the warnings and insights from experts like Brian Cox, we're more prepared than ever to understand and appreciate what's about to unfold in the cosmos above us.